This is a short guide about how to summarize or group data in Tablexplore. And this is usually done by either aggregation or pivoting of tables. And to start off, I'm just going to show a very quick example of aggregating using a set of dummy data here with 100 rows and we'll say 4 columns, which includes a categorical column called label, which is just a selection of 5 different colors, and the other data is simply artificial values. So say I want to figure out what is the sum of all the values in a given column per category, which is the label column. I go to the toolbar here and I choose the aggregation dialog. So that opens a new window with 3 boxes on the left. And the first box here is indicating which column we want to group by, which is the label, and then which values we want to use for aggregation. Say we select the first column and which function we want to apply to that. So say we want the sum, and then I press apply. The result appears here in the middle as a new table. So it's the sum of all the values for each categorical value in label, which is the 5 colors, just for that column. If I want, I can add any other column with values in it and it'll produce this. I can copy this to a new sheet or to the clipboard, or here like this I can send it to a subtable, which is a temporary table that appears below the main one. And if I close the dialog here just to show the result, say I want to visualize this, I can just for convenience set the color as the index and then plot, and then plot that as a bar plot. So that shows us the sum of each column over within each categorical value. Now say we want, there's another way to do this, which is a more direct way in terms of plotting. If I select the entire main table here, I'll close this one, and I go to the plot dialog on the right and I choose group by label instead of the regular kind of plot, and I just plot that table again. This gives us a very similar result because it's internally doing the same kind of operation, except in this case it's showing us the mean value. That's what it does by default when we choose group by, and the bars here are the standard deviations. So it's showing us the distribution of the values. So it's a more shorthand way to do that grouping. So to take a more realistic example, I'll go back to the datasets menu and choose Titanic. And this is a table of details about all the passengers on the Titanic, like whether they survived, what their sex was, their age, and the class they were in. So say we want to group over some of these categories and find the age characteristics. We can go back to the aggregation dialog, and we can see that we have all the columns listed here. I'm going to choose survived and sex, and then I'm going to aggregate on age and find the mean value, the mean age within each category. So that's what's shown here. So we have 2 categorical columns and the mean age value. I'm going to copy that to a new sheet and close the dialog. So if we want to plot this, simply selecting everything and just plotting it will give us a confusing result. If I show you a bar plot, that's partly because survived is a integer value, and here it's plotting it as an actual bar, which is what we want because it's a category. One way to deal with this is to set the survived as the index, and the reason I do that is that that's what's chosen as the x-axis. So when I plot now by selecting all the values, we have 4 bars, one for each row, and these are the mean ages in each category. But you'll notice we can't tell what the sex is. The sex is ignored here because it's not an integer. It's a set of string values. They're not numeric. I can handle this by going to group by and choosing sex in the group by menu, and then replotting. and that gives us a breakdown by male or female. Now, if I choose multiple subplots, then we get a somewhat clearer result, because that's split both of the male and female categories into individual plots, and they're broken down by survived or not survived. So the other type of summarizing, table summarizing, is pivoting. And this is much easier to show than to explain verbally. So I'm going to use a large table from Our World in Data on COVID-19 metrics. So these are given per date, per country, and then we have a load of metrics such as case numbers, vaccination status, and so on. So we can get an overview of the table if we choose table info here. And that shows us how many columns we have. So there's 64 columns, and what each column, the type of the column, most of them are numeric. The first 4 here are categorical, so they describe the country, that's the location here, and the date specific to that row. So we're only going to use a couple of these metrics for an example. It's not important really which one. You can see the total. There's a lot of columns beginning with total. Those are cumulative, and then there's some others that are the daily values. So that's probably what we'll use here. So if I close this and I go to the pivot dialog, what we want to do is to essentially transform the table into one where we have a specific metric, and we have a column for each country, and every row will be a date, and that will allow us to plot a specific metric that we extract from this table, which is has got lots of measurements on it, and more easily. So if I the only really easy way to describe this is to show it. So if I choose the date as the index, that will mean in our new table the rows will be the date, and then our values are, we will pick new cases, so that will be the cases per day, and then we're going to have a column for each country, which is location. And I'm going to have now in this case the aggregation function may not be it may be, we're going to use sum as the default, but in this case the values should be unique for that combination of settings that I've chosen, so that although I've chosen sum, it should only be a single value that it's summing, so it's simply extracting it from the table. When I say apply, I get as I said, because we've chosen the date as the index, we get a new table with the date for each row, and then we can see that we have a column for each country or location, and that these values are the new cases for those countries at that date. So we've only extracted a much smaller set of data specific to these new cases metric from this, because this table is actually, I forgot to mention, you can see how large it is. If we look in the bottom left here, it shows the number of rows and columns in the table. We have 120,000 rows here. So obviously plotting something like this, we have to reduce it down often to get something meaningful from it. So if I copy this to a new sheet, and we'll just call it pivot cases, and then close this dialog. So here's our new table, and we can I'll select an arbitrary column here and plot it, and what that is as I said, the new cases per day. The noise in the data is to do with how data is collected on a weekly basis. It's not that important, but just to show another feature, I'll arbitrarily here just pick a country. This is Canada. I'll turn down the line width and plot it again. Say I want to just as a final example to smooth out this data after we've extracted it here, I can select to transform or resample this column, and I'm going to take the rolling mean over 7 days, 7-day window, we'll say 14 days. And that produces a new column. I'm going to plot them both together just to show the difference. So I'll actually make so you can see the blue line is the rolling mean value, so it's essentially smoothed out over that time period. So it just allows us to visualize the data much more easily. So that's pivoting. It is a complex operation, and it can be quite confusing. So the best thing is to basically practice it until you get the idea.